Welcome to my statistics tutorial. Today we are exploring a fascinating topic in probability and certainty, draw a probability distribution, variable transformation, and checking for independence between the variables. So we will work through a problem step by step to understand how transformation impairs draw densities and how we can determine the independence of variables. So this is you will usually see this similar question in your exam in the university. So I excited to guide you through this question. So let's get started. So we have the two random variable labeled as a x1 and x2. So we share a joint variable density function of PDF which is given to be equal to 2. So here equal to 2 here. So this PDF property density function applies over a specific range. X1 is larger than 0, less than x2, and x2 is also less than 1. So now we apply transformation where we define the two new variables. We can call this y1 and y2, and here one is defined as the ratio of x1 to x2, while y2 is similar equal to x2. So the questions ask us to accomplish three tasks. So the first task is find the draw identity function of the variables y1 and y2. The second question determine the marginal density function for each of y1 and y2 separately. So far, we have to define the whether y1 and y2 are independent of each other. So with this question in mind, let's dive into this to how to do this. So our first task is to find the draw identity function of y1 and y2 to begin in. We need to rewrite the original variable x1 and x2 in terms of transformation of variable first. Okay, so to do this, so with the transformation given us, we can expect that x1 as the equal to y1 multiple x2 also equal to y1 multiple y2. Okay, so x2 is equal to y2. So now the property transform a draw identity function. We need to calculate the Jacobian. So determine the Jacobian allows us to adjust for the training in the variable, ensuring the transformation is accuracy. So so how to calculate this? So this partial. Let me see. This is the partial x1 x2 divided by partial y1 y2 y sub 2. So it's equal to absolute value. This is the partial x1 divided by partial y1. This is the partial x1 divided by partial y2. And then partial x2 divided by partial y1. Partial x2 divided by partial y2. So we got this matrix. So this y2, this is a y1 is symbol. So this is 0, right? Because you d this one, you divide this one, you got 0, and then you got 1 here. Okay, got 1 here. Okay. So now we found the Jacobian, and then we need to do the A first. Need to do the A. So part A. Let me see. So F y1 y2 is so we need to find this one because this is y2. Okay, so the draw identity functions of y1 and y2 is is 2 y2 because where the y1 is less than 0 and y2 is less than 1. Okay, so now solve the question 2. Question 2. So question 2, we need to find of f1, fy1. So this is marginal density function of y1 and y2. Y1 first. So 0 for 1. Here is 2. Okay, so equal to y2. Okay, so we found the marginal density function of y2 is equal to integrate 0 to 1 and 0 from 1 and then 2 multiple y2 dy1, right? So this is a y2, 2 multiple y2 and y1 and then 0 and 1 and finally we got y2, 2 multiple 2y2. Okay, so this is a part B. There's a part C, but this is part B. Part B, are they independent? So you have to trust one thing. So we have to find that if the f y1, y2 whether equal to fy multiple and fy2, fy1's multiple fy2, right? If this is equal, so they are independent. So we found that times 2y because it's 2y, 2y2. So conclusion, therefore, they are independent. Okay, so that's it. So and thank you for watching. We divided joy density function for transformed variable x y1 and y2 using Jacobian and the original density function. So we calculated the marginal density function for y1 and y2 by integrating over the respective variable. So lastly, we confirmed that y1 and y2 are independent because they are joint density function is equal to the product of their marginal density. So the problem integrate the importance of transformation and independence in the statistics analysis. Understanding these concepts can help us analyze data distribution and relations between variables more efficiently. Okay, so thank you so much for watching. I hope this breakdown of the joy probability distribution, transformation, and independence was helpful. Please like, subscribe, and click the notification bell if you want more content on statistics probability. So if you have any question or comment, feel free to let them below. I will see you in the next video. So bye bye.